In this video, I'll be working through the question you can see on the screen here from the summer 2025 Cambridge A-Level Maths paper 3.3. I'm going to try and show you how to do this question and not just the solution. So you may need to pause and rewatch certain parts of the video. If you're looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around on my channel. Okay, let's get into the maths. In question 11, they give us this formula and this graph here, and they want you to show something. Show that tan of 2a is equal minus 4a when x equals a. I would try not to worry about that. Often when they give you the answer like that, show this. I suggest to students, just try the question without thinking about it until later. There will come a point where you want to look at it and make your answer look like that answer. But for now, you should just think that they're asking you about the maximum point, the maximum of an equation. So what you should be thinking is dy dx. And what's more, at the maximum, it equals 0. So we now have an equation to start. They wanted you to find an equation. We now have an equation. This is the equation they wanted you to start off with. So our course is clear. We need to differentiate this. Whenever I have a square root, especially in differentiation, I nearly always just rewrite it as x to the power of a half. So let's rewrite everything there. So I want to differentiate this. This is two terms. So we're going to use the product rule. And within the product rule, we're even going to use the chain rule, although it's not too bad on this one. Okay, so the product rule tells us that, let's differentiate the first one. That becomes a half times x to the power of minus a half. Leave the second one alone. Sine 2x. Plus, leave the first one alone. That's x to the half. Multiplied by the derivative of the second one. The derivative of cosine is, the derivative of sine is cosine. Or I should say, we have a problem here. 2x is too complicated to do. So we would need to use the chain rule. We can do it in our head though. The sine of something, the derivative of sine of something with respect to something is cosine of something. Use any letter you want, u or something there. But we've replaced something there. So we need to get the derivative of that something and multiply it by. That something was 2x. The derivative of 2x is 2, just multiply it by that. Most students just remember the derivative of an easy thing like this, a multiple of x is just do it as normal and multiply by the number. But still, I think it's better to learn it the proper way. Okay, this all equals 0. This is an equation. We can clean this up. Let's move one of them over the equals. Let's move this guy over the equals. And we'll change these to the power of a halves back into the square roots. So this will become minus a half, minus a half times sine 2x. And this square root of, this is a minus square root. So that means it's on the bottom row. So that's divided by square root of x. And we'd leave this on the other side. That'd be a square root of x, 2 square root of x times cosine 2x. Now at this point, I looked at the answer they gave us. The answer has tan in it. It has a 4a in it. But the tan is what jumped out at me. Because my answer has a sine and a cosine. They go together to make tan. Before that, I guess we could clean a lot of this up. There's a 2 and a square root of x on the bottom over here. Let's multiply both of them across. We'd just be left with a minus sine 2x on this side. This times 2 is 4. Square root of x by square root of x is x. And we leave cosine 2x there. We now have 4 times something. That's what we wanted. But I wouldn't worry about that too much yet. Let's just get that tan. We have a sine 2x, a cosine 2x. If we divide both sides by cosine, we'll get that. That just becomes pretty much the answer. Minus tan 2x is equal 4x. A couple of problems. Well, first of all, they want the minus the other way. So that's tan 2x is equal minus 4x. One problem really, they wanted a. They want tangent of 2a is equal minus 4a. At any point after this line, or in this line even, we could have replaced x with a, because they told you that x was equal to a at this point. That's what we were doing here. We were at this point because we were at equal 0. So at any point you want, you could have put a in. I'll just wait till the end. So that's tan of 2a is equal minus 4a. And that's the answer to part A. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. For part B, they want you to show by calculation that A is between 0.9 and 0.95. This question comes up all the time, and there's a couple of ways to do it, but my main way to do it is just fill in the two numbers they gave you, so 9, 5, to this equation. They've given you this answer already. This is two sides to this equation, the left side and the right side. If we think of these as separate functions and fill these numbers in, we're gonna, I'm skipping to the end a bit, but if we fill these numbers in and if we find out this number is bigger than that one, and then if we fill the other number in and find out it's less than that one, it means they must cross in between. If we find out the left side and it looks like this, and then it looks like, I don't know, this or something, they must meet somewhere. The answer must be in the middle. Let me show you a bit more. Well, that's the main idea. I'll write exactly what I think you should do in the exam, or certainly enough that you will get full marks in the exam. I am going to find tan 2a at this point, and I'm going to find minus 4a. I'm going to put these both in the calculator. I have the answer already out here. If you put 0.9, tan of 2 times 0.9 into the calculator, you will get minus 4.286, and if you put this in, you get minus 3.6. At this point, I would write something like, the tan 2a is less than minus 4a. And I do the same over here, tan 2a minus 4a, find out what both of them are. This one is minus 2.927, this is minus 3.8. This time I'd point out that tan 2a is bigger than minus 4a. And that would be it. I'd write therefore, therefore a is bigger than 0.9 or less than, is between 0.9 and 0.95. This is enough to show me. For the reason I said here, this should be on top of each other, I suppose. If I put in like 0.9, 0.95, if one of them's above the other and the other is below the other, no matter how you get from here to over here, once you can't go back in yourself, and I don't care if I do it 3-4 times, there has to be at least one answer between these 2 points. Maybe there's 2 or 3 answers, but there has to be at least one answer. There's no other way for this guy to get to here without crossing these two. So there has to be a solution in between. That's all this is saying. In part C, this is a question I don't think I've seen before, and I would forgive a lot of students for not knowing what they even wanted you to do here. I think most people will be able to do the next part D. It comes up every year. But what are they asking you here? Prove or to show that this converges to A. How do we do that? We know about A up here, and this looks very similar, but not quite the same. What do they want you to do? Well, what they want you to do is show that this is the same as this. If it converges at A, first of all, the nth x and the xn plus 1, as we'll do in the next part, they'll start being the same number if we go further down the iterations. So I can first of all rewrite this as A equals 1 over 2 pi minus the inverse tan of 4A. So that's the first thing I could do. they might try and give you a mark for that. And you could try just multiply this out, multiply both sides by 2. 2a is equal, and then maybe take pi off, take pi away. So 2a minus pi is equal to the minus inverse tan of 4a. We could get multiply both sides by minus first of all. That becomes a plus, that becomes a minus. And we could get tangent of both sides. The left side we'd get the tangent of minus 2a plus pi is equal 4a. There's some similarities here, but not quite. Really the meat of this question is they want you to show that this is the same as this. So I'll do that by drawing it out, and hopefully some students see it, because it is at this point we're getting a little more common. Tangent looks like this, whereas this is 90 degrees, or pi over 2. This here is pi, this is 2 pi. Tangent repeats every pi. It's identical, it's 0, it's 0, it's 0, every pi. It's, I don't know, let's say this is 5. Add pi on, it's still 5. Add pi on, it's still 5. Adding pi on does nothing. It doesn't change the answer for tan. So this answer is identical to this. That still equals 4a. Now we're nearly there. You don't have to explain why you know this, but I'll talk through it. This is then the same as minus tan 2a. What I mean, you don't have to explain this. You don't have to write anything I'm about to say down, but hopefully you do know this. A minus in here. So for example, if I put in, let's say, I don't know, pi over 6, and I get an answer here. If I put in minus pi over 6, I get a symmetrical answer. If I got plus, I don't know what the answer is there. Let's say 1 over square root of 2. I don't know what it is. The answer down here is minus 1 over square root of 2. If I put in pi, I get 0. If I put in minus pi, I get minus 0. Still the same thing. If I put in this number here, let's say 4. Pi plus a small bit, 4. I get this number. If I put in minus 4, I'll get the same thing, just a minus. That's what we're saying here. So this is still equal 4a. Change sign on both sides, and we get what's up there. Minus 4a. So this is the same as this. So the answer to this is clearly a, because we have a in it. This converges to a. That's what they want you to show. But I think a lot of students would have gone, sorry, what do you want? I guess the hint here would have been just play around with this. Play around with it, and you hopefully could have got to a line that looked something like this. And once you got here, to get that mark, you probably could have got 1 mark to get to there. To get that next mark, they really wanted you to notice that this is the same as this. This is the same as this. And boom, we're back to this original one. On to part D. Now you are probably tired if you're doing this exam. It's the last question of the exam. Although you don't have to do the questions in order, but most people do. So you're quite tired. Still, there's no excuse not to get these marks. It's the same question, nearly guaranteed every year. You have a formula that maybe you have to find yourself, or usually they give it to you, like they've done here, and we just have to put numbers in until we find an answer. We get to decide the first number. Let me do it all here, because I'll put it all on top of each other. We get to decide the first number, the first guess we make. Sometimes they tell us that. In this question, they did tell us that the answer was between 0.9 and 0.95. So I will guess my first answer is 0.925. Doesn't matter. You could guess 0.9, you could guess 0.95, you could guess 1 if you wanted. It's fine. What we do next is we use this formula to find our next number, our x1. And that's just by filling this in. You'll see what I mean here. It's a half multiplied by pi, take away the inverse tangent of 4 times. If it's x1 is out here, this must be x0. because if x1 is here, n plus 1, this is 1 less. Another way to write this would be xn and n minus 1. That's the way I learned it, at least. So if x1 is here, x0 must be in here. So this is 4 times x0, or in this case 0.925. You just put all that in on your calculator and you'll get well, you might have a different number if you started at a different number, but if you start the same as mine, you get 0.917380. They asked to make sure you tell them six digits here, but they also wanted the final answer to have 4 digits. So I'll write both of them. 0.9174 would be the 4 digits. What we're going to do is we're just going to do this as many times as it takes until our 4-digit number stops changing. Basically, so it repeats twice. Yeah, and that's it. You just have to put this in your calculator. There is one shortcut you can do. I'll write it out here. What I do is I put this number in on my calculator, my first guess, and I press equals. That makes your calculator remember this number as the answer. Then I put this whole formula in the calculator all in one go. I put in lots of brackets to make sure I don't mess up. And instead of this here, there's a button on your calculator that is answer. Instead of this number, I press this button at this point, and I close all my brackets and I press equals. I still get this number. But the magical thing that's happened now is your calculator now remembers this formula. It remembers, instead of the number here, to always use the answer. And now the new answer in your calculator's memory is this one. So if you press equals just one more time, it'll do this whole formula for you with this new number in it, and you'll get 0.918425, which is the same as 0.9184. Not the same, so we stay going. Third guess, again, just press equals on my calculator, it does it. And 0.918281, which is the same as 0.9183. Not the same yet, we have to stay going. In paper 3-2, in the same year as this, they had to do this like 8 times. I've never seen that much. Usually it's 3 or 4 times. This is the fourth iteration. Fourth iteration is 0.918301, which that rounds off to 9183, same as this. So I can confidently say my final answer is 9183. That's correct to 4 decimal places. Because if you've done this trick I told you about, you can actually just press equals in your calculator 5-6 more times, and it will just get better and better answers. So in this case, this guy converges quite quickly, because that's what tan goes off quite quickly. So the fully correct answer, you don't need it, the exam didn't ask for it, is this is to 8-9 decimal places. But that's perfectly correct. But that's obviously correct to 4 decimal places. Okay, that's it for question 11 and this whole paper. If you have any questions for me, or you see any mistakes I made, or just any questions in general, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day.